So I work for the National Park Service. I'm a supervisory restoration ecologist, and I've worked for 34 years for the National Park Service in many different places as a seasonal early in my career, and then have been based at Lake Mead National Recreation Area since 1991, and actually started as a seasonal back in '88. And I've worked in mostly vegetation management my whole career. And so this presentation is going to cover a lot of content. I'm going to go over many different high priority invasive plant species that affect natural ecosystems. And I'm going to go over different biology and different life forms of them. So I'm going to start out with some of the smallest of the invasive plants and move up to the largest ones. And then going to start off basically introducing the invasive plant management team that we have and the different work that we do in the whole regional area that we cover. And then I also included some specific slides on some of the Gold Butte projects that we have, some highlights, just mostly treatment maps. And also just be aware, I have a tremendous amount of slides and images here. I think I've got over 94 slides in this PowerPoint that I've edited some for this, but a lot of the slides I've maintained, I've presented it in the last 9 months at different forums that are mostly technical in nature. So there are many slides that I'm going to really zip through very quickly that I think are probably, less appropriate for the content. So anyway, I'll get started here. Let's see. So we're part of the Biological Resource Management Division of the Park Service, the invasive plant management teams. There's 16 of them across the country, and here's a map that designates some of the areas that they cover and some of the park units they support. All the way from Alaska through the Pacific Islands to the Florida Caribbean up to the Northeast and all parts in the middle. And here's some of our specific regional coverage areas. So we cover all the desert parks in California, like Death Valley, Manzanar, Mojave National Preserve, Joshua Tree, all the southern Utah parks, like Zion and Capitol Reef and Canyonlands and Arches, and we've worked a lot extensively in Arizona parks as well, like Grand Canyon, and covered into Colorado and even Texas and New Mexico. We've served over 30 different national park units with our team. The program was actually prototyped and developed here with our team at Lake Mead. And then it was adopted. Congress funded it on a large scale. They liked it. The Park Service liked the concept of traveling crews and providing the expertise to parks so that each park doesn't have to create that same capacity. And so now that's what's developed into the multiple team program since 1999 or 2000 is when the congressional funding came in. We used to be called the Lake Mead Exotic Plant Management Team. We were all exotic plant management teams, but about 5 years ago, we changed to the common terminology now of invasive plant management team. Although exotic is still an appropriate name for a lot of the focus of invasive species that we focus on. But so we have a traveling crew, up to 20 people, and we support greater than 20 national park units in multiple states. And one thing that we really pride ourselves in is we have a lot of interagency partnerships. So we've worked in over a dozen U.S. Fish and Wildlife Service refuges in the National Refuge System, all the way from New Mexico, all the way down the Colorado River system, on Arizona and California and Nevada. such as ash meadows here, one of the photos featured. We work throughout the Bureau of Land Management in the state of Nevada. We have agreements all the way up to Winnemucca and Elko. Worked a lot with the Ely district in the past, and we do a significant amount of work in Battle Mountain, Nevada, for their district, and of course Southern Nevada district. And we have agreements with the U.S. Forest Service. Coconino National Forest is a current one, and also with the Spring Mountains National Recreation Area. We also have agreements pretty long-term now with the Desert Conservation Program in Clark County, Nevada. So working on a lot of their riparian systems on the Muddy River, the Virgin River, and then also the Boulder City Conservation Easement, just in the El Dorado Valley, just south of Boulder City. We have a relatively new agreement with the Maricopa County in Arizona, working in their county parks like Cave Creek Park, Spur Cross Ranch Park, and many other entities. So we pride ourselves in a lot of partnerships. So we get a small amount of funding, base funding from the Park Service to support park units. And then what we've done with all these agreements, kind of if you build it, they will come concept. All these other partners come to us and would like our services. And so we do that through up to 5-year agreements with each of these partners, and they provide funding. And that's why our crew is so large. With just the Park Service funding alone, we'd only have about a 2 or 3 person crew, but instead we can have up to 20. Let's see, moving the slide. So here's some of our regional, this kind of our base playground, as we cover pretty much most of the state of Nevada, all the southern half of Utah, a lot of Arizona in there, and then all the California polygons you see there. And what we do, we're trained crew that provides the expertise and the skilled labor. It's very kind of a unique quality to have. There's not a lot of this, not a lot of the model in the private sector, the private industry. There are some examples across the country, but not very many. And so a lot of this is conducive to interagency government partnership work. That's one of the goals of our team in the invasive plant management program. And the Park Service was to professionalize the invasive plant management industry within our organization, because it is such a massive problem for all the land management agencies, and the Park Service in particular as well. So we're developing the capacity in-house. That's our big goal of our team. And so in summary, this presentation is going to cover a lot of various, invasive plant species, their life forms and biology, some of the characteristics they have. I'm going to go into some control strategies and methodologies, and some of the effective herbicides. I'll probably skip through some of that portion quite a bit, but I do want to at least expose you to the different types of herbicides that are out there, and then that we use, and some of the challenges that we have with our type of work, and highlight some projects with lots of photos and maps. And so I'll move on. And invasive annual forb, I'll start with invasive annual forb species. So a lot of text in here, but these are some of the common invasive annual forbs that are like Sahara mustard. There's Malta, star thistle, Russian thistle, tumbleweed, which most people are familiar with. That's a real nuisance weed. Halogeton, a really tiny one called burr buttercup I'll feature. There's 5-hook Bassia, kochia, and then these larger thistles as well. Some of the common characteristics of invasive annual forb species is that they have short lifespans. So they grow less than a year. From the time they germinate to the time they senesce or die and dry up, it's less than a year, and usually it's less than 6 months for many of these species. Sometimes even 3 to 4 months from germination to seed production. So they're seed bank species is how we refer to them in the industry, is that they have a short life, and they got to produce seed so that they can have potential future generations, and those are basically end up in the seed bank. in general, in our ecosystem, like the Mojave Desert and some of the arid systems, there's usually there's winter annuals, and then there's summer annuals. So there's warm season and cold season. And all of these invasive annual forb species are really weather dependent. And a lot of the driving factor in their production is precipitation and the timing of the precipitation. So they need like these winter annuals, which many of these are. They usually will need fall precipitation, like October, November, December, to germinate. Once it cools off, the soil temperatures get cooler, and then they germinate, and then they'll need subsequent rain periodically afterwards to grow and to get larger in biology and in their size. And they start out with small basal rosettes, and after the cotyledon stage, and then they typically shoot. They grow a shoot, which is a bolting stage, and then they flower, and then they go into seed production. So the treatment timing is short. That's the challenge with these annual species. It's a very short window, and many of them are really landscape scale. So you find them widespread across the landscape, but also some of them just aren't very competitive either, and they're limited to disturbed areas, roadsides or places that are constantly being disturbed. They also respond a lot to other disturbances that are natural, let's say like wildfire or flood events. And generally, most cases aren't very competitive to the perennial species. So they'll become a problem in a short term, maybe a year or two, and then sometimes phase out and get outcompeted with other perennial species. And then even some of these are more like, they're just an aesthetic nuisance, like this lower left bullet here. Aesthetic nuisance is what mostly like Russian thistle is. It's very common and widespread, and usually just a nuisance, more so than an ecosystem disruptor. So here's some of the control treatments we have. The herbicides are all listed on the right. And then the strategy of these to control these is really to stop seed production. Okay. So you want to get these treatments in no matter what the treatment is, whether it's chemical or mechanical, before they produce seed. And that way you limit the future population potential anyway. And many of these, again, are across the landscape. So you have to be very specific and have site objectives in most cases. Whether it's a restoration site or a post-construction site or post-wildfire, building a trailhead or trails, that's usually a good idea to try to plan for these types of weed treatments to respond to that. Roadsides, utility corridors, are common areas to treat these. And one thing that's important to know is if you could stop the disturbance, you basically stop the disturbance regime, then these weeds will usually fade out and fade away. They, again, will get outcompeted. But if you have a continuous disturbance regime, they will be a continuous problem. So here's some examples of Russian thistle, tumbleweeds, another name. A lot of these photos here, the top two, the middle and the left and the lower right, are at Spring Mountains National Recreation Area up in Kyle Canyon. We've controlled a lot of that around some of the trailheads and some of where the visitor center was built. Now it's been, I don't know, a good 8 to 10 years, but there was a massive problem with Russian thistle for the first 2 or 3 years due to the construction and soil disturbance. And we did lots of control efforts in there until the native plants established. And some more control methodologies. So you can do, with chemicals, you can do what we call a pre-emergent, where you anticipate areas of germination So you get the herbicide out on the ground before it germinates, or basically you do this in areas that you want to manage it for. So in places you don't want to tolerate these annual weeds, it's a good method to be, it's proactive. You get the herbicide out in a certain section, and then it'll germinate. If it does germinate, then it dies quickly, shortly after. The post-emergent is can be challenging because you have to get out there at the right time, and then there's multiple generations that occur during the right season. So there's cohorts, so multiple generations. So if you're just treating only the emerged species, you're having to go out there repeatedly. Some of the examples of these photos are at Manzanar National Historic Site in the Owens Valley. It's a Japanese internment camp during World War II. It's an historical site, and we assist the park there in managing Russian thistle. Again, areas they want to interpret where the old barracks were and around the visitor center, and there's ball fields and things that they don't want these weeds in. And they get overwhelmed. Some of their staff have had to respond with hoeing or hand pulling or spot spraying with a non-soil residual herbicide, and they just can't keep up with it. So we've come in these situations, it's appropriate to do pre-emergent. Here's some examples of the effectiveness of the pre-emergent. On the left is the blue. The blue is a colorant. We put a dye in to so so our crews know where the herbicide was applied and where it wasn't. And then these photos, 3 months later on these sites show where the herbicide was, and these are barrack foundations with numbers on them, and they have interpretation about them. So you can actually see where the barrack footprint was, and then all the green surrounding these photos is Russian thistle. So it's places we did not apply the herbicide, and that's would just be a straight field of Russian thistle that you couldn't even tell where the facility was. And there's an aerial photo that actually you can show it. And some of these can last up to 2 or 3 years of effectiveness. So another common one is 5-hook bassia, which is more of a riparian type species that gets much larger than Russian thistle. It can get chest high and have huge production. It's a warm season species, and actually Russian thistle is as well. So it only responds to warm summer season. So it usually starts developing around here in April, May, June, July, and August. All through it, you'll have multiple cohorts responding to rain events. An example of some of this 5-hook bassia is down here in the Wetlands Park. We have a partnership, I forgot to mention, long terms for over 23 years with the Clark County Wetlands Park and Nature Preserve. And there's some wildfires that were driven mostly by tamarisk near this Samboid silver bowl here. And we had a huge flush of this 5-hook bassia. That's how nasty it can get without treating. And other examples are here at the Wetlands Park on the lower right is a re-veg site. They've got the irrigation tubing in, they're putting in native plants after they construct the weirs. And so this is another example of a place where you may want to manage these annual weeds, because they can alter your success of your restoration, and they can affect the trajectory. Again, these are so widespread, most of these weeds. It's purely just control. It's on a site-based, where you prioritize, it's very important. They're not going to be eradicated. That's not a management goal in most scenarios. Puncture vine is another warm season, and Halogeton and kochia. Puncture vines are real nasty. This upper left here, it grows really low growing, and a goat head is another common name that the seed has, and it'll puncture bicycle tires and get in your feet and shoes. It's a real nasty weed to have. You don't want it around trailheads or roadsides, things like that. So here's the smallest weed we've ever managed, or at least that I've ever managed. It's a belly flower, literally. It's a burr buttercup. Most of it's about the size of a dime or a quarter as far as diameter, and only an inch or two at the most at height, sometimes smaller. We manage this in the Spring Mountains National Recreation Area. It's common in Idaho and different parts of central and northern Nevada and Utah. It's not too widespread in southern Nevada. There is a lot of it in the Cold Creek area and the Willow Creek area. And so we do control efforts there. It's certainly not eradicatable in those sites. There's a lot of private land as well, and it's pretty widespread sometimes. It's a very early, this is one of the earliest annuals I've seen. It germinates kind of right after snowmelt. And it's usually, it grows within, just matures within 3 or 4 months. Usually by June 1st, this stuff's all crispy and brown. April and May is generally a good time, in March to treat it. So we're in the landscape. We prioritize, like here's this lower right is the Bonanza trailhead, goes into the Bonanza wilderness. We want to keep it out. We've detected it in some of these trailheads, and we don't want to get it into the backcountry. It does have a little burr on it when it matures, and it can get onto dogs' fur and foot pads and hiking boots and shoelaces and get transported into the backcountry or wilderness areas. So we want to keep it out of that, and those trails can be vectors. So we're really prioritizing around the Bonanza trailhead and the road going up to it from Cold Creek. So we're treating along the roadsides and beyond in some of those areas. Sahara mustard, I hope most of you know about it or heard of it. It's probably one of the most invasive of annual forbs in the Mojave and Sonoran deserts. Like I mentioned, several of these examples I've given, like Russian thistle and five-hook bassia, halogeton, puncture vine even to most extent, are really limited to disturbed areas and roadsides and urban areas and alleys, things like that. They really don't do well getting into the natural landscapes very much. But Sahara mustard definitely can and has. It's spread throughout into natural undisturbed areas. And so that's why it's become one of the highest priorities to manage in southern Nevada. This is an example. This area here, these photos are taken at the Mormon Mesa ACEC, Area of Critical Environmental Concern, and it's just north of I-15 off the Mormon Mesa, right before you drop down to go into the Mesquite area. And so it's just east of the Logandale, Moapa, and Glendale, just east of there. And again, this weed is widespread throughout the Las Vegas Valley. It's in urban areas and it's in natural areas all around. It's variable. Again, some years you don't really find much of it at all, and then other years it's exploding. And some of the biggest problems that can grow in the interspaces underneath or between the shrubs. And it can compete. It's a winter annual, so this one will germinate in usually in like November, December. It'll be tiny. If you get the right weather afterwards, it'll grow and get real big, and by March, April. So this one has a more of probably a 6-month growth window in general from germination. And it's important on the control strategies with these. When they're really small, these little cotyledons or small basal rosettes, it's pretty hard to detect them. So if you go out there on the ground and try to control them, you do your best, but you'll miss a significant amount of the population. You come back a month or 6 weeks later and be like, wow, you start seeing all these once they bolt and flower, like some of these photos, they become real obvious. And so that's a challenge with the timing. It's you certainly get more you detect more of them when it's later in their life stage. The problem with that is you start getting, you wait too long, and then you can actually get seed production of areas that you can't get to because of your short time period. So it's a big balance of managing that. And again, it's high variability. This can, you can go 2 or 3 years without really seeing much of this in some of the natural areas. Usually you'll see it on every year somewhere around a roadside, or little pockets of it in the Vegas Valley. Here's some examples we've done along actually along the Arizona border with Mexico in the Gila Mountains, and this is part of the Marine Corps lands, which we were protecting fringe-toed lizard habitat in the sand dunes. And so you can be effective controlling it in isolated areas. It's the Barry Goldwater Range. These are these two right here are scientists with the University of Arizona, research botanist, Jim Malusa and Max Lee, and they put in they monitor our treatments for effectiveness, and they've determined that our treatment areas are working, and we get native plants in those, and they put control plots where we actually don't do treatments. So it's pretty well done, well documented, the effectiveness of it. But again, it's isolated areas. We're not treating all of it. Here's some examples of some habitats that we're treating there. Now, Malta star thistle is another annual species. Some of these examples are at Tule Springs Fossil Beds National Monument in the North Las Vegas area. This photo on the right is, you can kind of see some of the last years or the dried up heads of the star thistle, and it does have it's thistle thorns on it. And then all this green stuff here is just the tiny little rosettes of the Malta star thistle. So it goes through these different stages. Here's an example of a population from the Paiute Golf Course. There was runoff from the irrigation. It was responding to that, and this red polygon here is the BLM Golden Triangle area that flows into Tule Springs Fossil Beds. And so we partnered with the BLM, and we've been treating this wash area here to keep the populations from expanding downstream. So the next group is exotic invasive annual grasses. These are the ones that really cause a lot of ecosystem disruptors, mainly because of the hazard fuel, the wildfire potential they have. And again, they're weather dependent. Most of these are all winter annuals as well. They respond to the same type of precip that Sahara mustard may, even though it's different. Whatever the weather is needed in the different germination events. Sometimes you'll see cheatgrass and red brome more consistently from year to year than you will something like a Sahara mustard. Again, these are red brome and cheatgrass are the ones that have really been responsible for, they connect the interspaces between, add fuel, hazard fuel to, and so the fires are much larger now in the Mojave system, usually driven by red brome and cheatgrass. I will mention though, I'm doing some consulting support for the York fire that just happened in the Mojave National Preserve, which is a partner of ours, and it's moved into the BLM Nevada area. And the good thing is most of that fire was not, well, it's not a great thing, but it's, it wasn't driven by these species. It was not a lot of red brome or cheatgrass in these sites. A lot of perennial grass and others. And it's an unfortunate event, but we are planning to do weed work following the fire to keep weeds from occupying the York fire. And we did it at the Dome fire as well. That happened in 2020. that burned up a lot of Joshua tree forest, unfortunately. So yeah, they're widespread a lot across the landscape, hazard wildfire. So where we manage this is along corridors, so hazard fuel breaks. You have to be very strategic because at least with our methods, all of our crew, we do ground-based applications, mostly backpack spraying, sometimes tank sprayers on a truck or a UTV. We're selective treatments. Our application methods are for restoration typically, and very selected, whereas really a lot of large scale control of this species should be done with helicopters and fixed wing airplanes to actually address the massive amounts of acreage efficiently. But we do real strategic applications. We've worked for many years at the Red Rock National Conservation Area, either post-fire or trying to protect areas that haven't burned. Things like the visitor center, any of the trails, the Calico Basin. So we're treating that usually with some like a post-emergent and some pre-emergent with soil residual herbicides to anticipate germination and just to reduce the hazard fuel. Again, it's a control by definition. It's not any kind of an eradication goal or objective anyway. These are some of the herbicides that you can use on the right. The strategies are you can do pre-emergent. Again, that's where you anticipate, where you have areas on the landscape you want zero tolerance, so you apply it before emergence. Downside of that is you may not get emergence, so then you just spent some money on it. You put chemical on the ground that you didn't need to. So I kind of like this combination sometimes in situations where we work with post-emergent herbicide response, and then some with soil residual quality. So you buy multiple years of treatment sometimes. A lot of the work is post-fire. And again, it's all site location strategy or perimeter protection around structures. We've worked for many years, decades at Zion National Park, keeping it out of the main canyon. We're putting a lot of treatments in around the historic lodge because we don't want that to burn up. So we're protecting unburned habitats or structures. And we're out to break up fuel continuity. I'll give you some examples. Here's some hazard fuel reduction breaks at Joshua Tree National Park. Treated up to 9 miles of road along both sides of it. To most of the fires, at least human-caused fires, will start along these roads or trails, campgrounds. So that's been prioritized to control it. And somebody throws a cigarette butt out the window, then chances are that's not going to ignite or carry far because we put treatments in there. And it's some of the strategies I like about this type of control that I've mentioned, that's selective, is that we may only be treating a small percentage of the landscape, sometimes less than 1% of an area or whatever, but we're protecting thousands and thousands and hundreds of thousands of acres by applying it strategically in those locations. So as opposed to treating all the core areas, we're just treating the areas that we think the fires have the most potential for ignition sites. So you can get kind of a lot of bang for your buck. Here's some of we did a lot of plot work with the USGS and Leslie DeFalco's group out of there. They were based out of Henderson. They moved to Boulder City, but here's a lot of work we were doing. And there were several wildfires in the Red Rock conservation area that we partnered with the BLM to control the red brome and cheatgrass in. And we're using backpack boom sprayers there. And we did a lot of plot work that was monitored. And then we also just do more widespread control as well. Took a lot of hiking in with packs and water to get to some of these sites. Some of our new partners were managing a lot of annuals is the Maricopa County, Spur Cross Ranch Park and Cave Creek. And there is a weed, a newer weed called stinknet that really exploded in the Phoenix area this year. It's been a problem for almost 10 years, but it really exploded. We're really starting to help manage the stinknet in that area. Big problem. I think we have I noticed a couple of members from our team, Riley Gronemeyer and Josh Vogel, who have both worked extensively on these projects, and they're, I think, listening in on this as well. So we think lots and lots of long hiking and hauling of water for these applications. Again, we're just working these polygons here on this map are treatment areas. We're treating just along the trails to keep the fire from potential out. Now moving up to perennial exotic grasses, fountain grass, buffalo grass, and some of these others these are perennial species. So you have a larger window to treat, but they're also, I think, can create more of an ecosystem impact because they're year round. So they can compete with the perennial shrubs and grasses that are native. And then, they're persistent. These ones we typically do spot treatments on. You can do some mechanical work. I'll highlight fountain grass is the #1 priority in southern Nevada as far as perennial grasses go. It's escaped. It's ornamental. Was commonly used. It's noxious, state noxious listed, so it's illegal to plant or to even possess in the state. However, there's a lot of remnants of these that are kind of quote grandfathered in, even though that's not the case. Technically, that's by law they're not allowed to be grandfathered. But we have relics, remnants, and they're spreading all over the place into washes and natural areas. So these are different control spot treatments with backpacks. We treat on Lake Mojave. I'll show you some slides on that. That's our longest term control area. So here's some of the fountain grass work. It was detected. It was the source, the point source is Laughlin, Nevada, from some of the casinos that were constructed in the 1990 area. And they planted fountain grass, and then the winds predominantly blow from the south, so it started spreading from the point source and moving up both sides of the Arizona and Nevada side of Lake Mojave. We detected it and started treating in 2003. We had 34,000 individuals that we counted when we treated from the boat. And then as 2022, we've actually finished our 2023, and I think we have a little over 700 individuals. So we've managed the population down and kept it from expanding, and it would probably be all the way through the Grand Canyon system if we weren't managing it. And one of the concerns is the Newberry Mountains over here. We started detecting it in spring, so it was windblown from this source, windblown into these wet areas, just like tamarisk does. And so we knew that was going to be a priority to treat. And the state listed it pretty much immediately. They were very proactive or responsive anyway to it. Here's a graph of some of our results of the red line is the number of fountain grass plants. The x-axis down here is the actual years treated, and then the blue is the gallons of herbicide used. So we're using, shows the amount of herbicide is much less, of course, with less plants. So that's a good thing. So some real challenging areas are like Joshua Tree National Park. Fountain grass is expanding, unfortunately, beyond like washes, which is where it's mainly limited to here in southern Nevada. We're starting to, in Joshua Tree, it's moving up these hillsides, these boulder and rocky steep slopes. And we're treating it there, and it's probably one of our most challenging projects that we have because they're remote hikes in, and then the terrain itself is very steep. And so there's a picture on the lower left of what we have to haul in the water to some of these remote areas to treat it, to control it. And there's some areas that we just can't get to. Buffalo grass is one that's a problem in southern Arizona, a big problem in Sonoran Desert, particularly like the Tucson area and a lot of the parks down there, natural areas. It's altered wildfire regimes. Phoenix, it's a problem. We have found this in the Boulder City Conservation Easement, and I'm going to say it was 2016 or 17. We detected 13 individual plants and treated them and have maintained it since. So we're trying to keep it out of southern Nevada. We also found it near the Davis Dam and in the Greenway Trail near Laughlin, and we've treated it progressively there. We actually found over a couple hundred there in after the Greenway. Both of these sites happened after construction and actually re-veg and seeding of these areas. So we think it could have been infiltrated with contaminated seed. But these are areas, a big priority. Again, this is in the Marine Corps and the Gila Mountains of a polygon here. These colors are buffalo grass. It was one of the only places in these remote canyons that it was found. We were there to do Sahara mustard control, like I mentioned earlier, and we found, or I saw on their data, they had buffalo grass. We went and found it and said, this is your priority. This should be your #1 priority, because we can manage buffalo grass in these locations to a zero tolerance strategy. Whereas Sahara mustard, we're just, like I've mentioned on some of these, that you're just site specific. You're only managing at certain sites that you prioritize. But buffalo grass in these areas, and certainly Nevada and in certain areas of Arizona, we can go with an eradication strategy. You should have zero tolerance, because if you wait or delay, it will be a big problem like the Tucson area, and then you're back to just managing it on site based only. Again, here's some of the example terrain in that polygon I showed you, the pictures on those maps. This is what it looks like on the ground. So it's mixed in with a lot of native plants, and we're selectively applying it. You can see some blue dye around here. That's how we can see this person right here is applying, on our crew, is applying to buffalo grass only, and this is Encilia brittlebush native that we will not affect with our treatments. This is Jim Malusa, the research botanist from the University of Arizona that I mentioned earlier, and Max Lee, that are also monitoring this. And these are some examples of some dead buffalo grass, or at least some orsa nest. Ravenna grass is one too, and it's a riparian one that's been managing in the Colorado Plateau. So Glen Canyon National Recreation Area, Grand Canyon, and we've actually found it in the Moapa National Wildlife Refuge about 20 years ago, and we've aggressively treated it. We've probably had less than 100 species, and we're aggressively treating it because it can be, this plant gets really big. It has a fluorescence that looks like a Phragmites or reed grass. So just for some of you, I mean, it can be a couple of meters or more, 3 or 4 meters tall, and is a large bunch grass and can outcompete riparian plant species and wash species. We put together we worked with Grand Canyon, Glen Canyon, and put together this poster, because this is an early detection species. It's not widespread. We're trying to keep it out of the Colorado River watershed. So we put in some information about it, diagnostics, how to identify it, and then some treatment examples. Here's some of the population. If you look at these red areas, these are Glen Canyon National Recreation Area, where we have to boat for 2 hours, and then we set up remote camps. Thankfully, we had a houseboat in some of our base camps, so that made it a little bit nicer, or quite a bit. And then we'd hike into these areas and treat the Ravenna grass, and it's only in these red areas out in the middle of nowhere. Here's some more close-up examples of how dominant this is. This might look like Phragmites, but it's Ravenna grass, and it's in very valuable riparian and spring areas. So you see cottonwoods and willows along here. So we're treating, these are some of the polygons that show the different treatment areas. So we map all our treatments for documentation. We'd have to boat in and then hike in. And these are some examples of the treatment areas. Again, this is early detection. We want zero tolerance in this region for it, really. Anywhere you find it, anywhere actually in North America, it's very controllable or eradicatable. So that's a unique strategy to have because it's not widespread yet. It does take a lot of, like this area here, thankfully, we were going to bring it, I was going to prescribe a helicopter to haul water in a large tank for us that we would have to use a 30 or 50 gallon tank because our backpacks just weren't really good, big enough tool. And then a flash flood came in. And the next year we came in and mopped it up after the flash flood and worked with backpacks, and it was much less work. So we utilized some of that to help us. But we have to transport these. These are framer packs with the herbicide with the active ingredient, and we find water sites, and these are mixed sites where we filter the water, get the water out, so we're not hiking water into some of these areas. This is the herbicide mix for it. It's basically glyphosate or Roundup, and Mazipure works well. Now, these are grasses, so it's a monocot. This is a palm tree. Invasive palm tree control is common in southern Nevada and some of the areas we work in Death Valley. And the wildlife refuges like Ash Meadows and Moapa Refuge, they literally get so dominant that they become fire hazards. These are examples of a treatment out at Ash Meadows after a wildfire. That was probably 20 some years ago. I included it in this is because it's a monocot, so it's closer to related to grass than it is to a perennial tree or so. So one effective method is we do this gas powered drilling, and then we squirt the herbicide from the nozzle we put right into the drill hole and squirt it in, and see some blue dye that's leaking out. That's some of the herbicide, and it's very effective at controlling large trees. We are working on, I thought I had a slide maybe longer. One of our biggest control projects recently was at Rogers and Blue Point Spring in the north shore of Lake Mead. There's large populations of this tree that we're controlling. And we've since cut down the slash with our fire program or fire crews, and then they did prescribe our slash burns afterwards. So now moving on to perennial herbaceous. I guess I'm already going more time than I thought. So bear with me here. These are the perennial herbaceous species. These are the hardest ones to control, mostly because they have rhizomatous root systems. So they're extensive. Their below ground biomass is much larger than what you see above ground. So it's very difficult to get the herbicide to translocate down deep into the extensive root systems that go laterally, not just, or horizontally, not just laterally. And you can scrape these with a bulldozer, you can hand pull them all you want, you'll get more of them. So really, unfortunately, one of the only methods to control this is with chemicals. There are some biocontrols for some of these. They're generally much slower spreaders. They're not like our annual weeds, so they don't generally occupy the whole landscape. They're very limited on a large scale, really limited to certain sites and soil and moisture types and regimes. But once they establish, they're very difficult and they're persistent and they're fairly resistant to control. They take multiple treatments. That's what I wanted to mention about the Ravenna grass is we had to treat. The seed bank comes back, and so it's important to treat in year 2 and 3 afterwards too. So these are some of The timing of it is larger for these perennials. You have a larger window. A lot of best time for these is sometimes fall because the herbicide can translocate down to the rhizomes and root systems better. And even some can be done in winter dormancy with certain herbicides. Here's some examples. Tall white top's pretty common problem in the wetlands park, and we've managed that down to basically zero tolerance. Whenever we find tall white top, we treat it right away. When in 2000, before all the weirs were getting constructed, we have over 500 gross infested acres of tall white top in the Las Vegas wash that was mostly intermixed with tamarisk. We actually had to survey it with a helicopter. There was so much of it. Now it's whenever we find, almost every site we find, like this one down here on the lower, is less than a quarter of an acre. That would be considered a big patch. These are some Russian knapweed. This is all the way up in the Spring Mountains, and then these are down at Ash Meadows National Wildlife Refuge. It's a riparian species. Camel thorn. This is one we've put a lot of effort into. It's not very widespread throughout the West. What we have, it's got the extensive rhizomes, and it's on the Virgin River. So basically below the Riverside Bridge, the one that takes you over to Gold Butte. It's actually below the first population in the river is maybe a mile below that bridge, and it goes all the way to Lake Mead. And it's very remote. It's very difficult access. We're going up and over the Mormon Mesa to get down to some of these. It's some remote hiking, lots of crossing rivers, lots of strategy with that, or which side of the river you're on. And it's been very challenging. We've suppressed it pretty well. It certainly hasn't moved upriver at all, and we're just continually. It's very difficult to get it all. Here's some typical scenario of our crews gridding out. This is along the Virgin River. It grows intermixed with arrowweed, which is a native, and screwbean mesquite, and sometimes honey mesquite, baccharis, a lot of baccharis, Salic, coyote willow as well. And we're doing selective treatments because in a lot of cases this is intermixed. So our methods are selectively treating the camel thorn and not harming the other species. We rarely find massive patches of it. I mean, there's some that we encounter that are monotypic, but they're all less than, more like 1/10 of an acre, maybe at the largest. But they are difficult to control. Here's some examples of the polygons of the Virgin River. Inventoried and treatment polygons of where it exists. Woody perennial species, tamarisk, Russian olive, Siberian elm. I'm going to speed up along here now. There's different methods of tamarisk control, mostly cut stump. They're all kind of small scale, expensive. There is mastication, which is occurring with heavy equipment. The tamarisk leaf beetle is a biocontrol that's worked very well on tamarisk. It's widespread. It defoliates the tamarisk. Doesn't always kill it. It'll refoliate, but it's working on a landscape scale in places that we can't actually do our methods. And these are examples of the browning tamarisk that you'll see. If you see tamarisk like this in the summer, this time of year, it's due to the beetle. So the tamarisk beetle's out. It's all over. It's in interchanges in the spaghetti bowl and the Henderson spaghetti bowl. There's beetles there. There's beetles all over the wetlands park. Virgin River is the most successful area that the tamarisk beetle has greatly reduced the tamarisk there. Here's some examples on Lake Mojave. It's very selective. It only eats tamarisk. Doesn't affect the natives, and the natives are allowed to expand actually naturally this way. Reduces the competition. This is the brown is tamarisk on the Canyonlands National Park on the Green River, I believe, and the green species is willow. Here's the distribution of the tamarisk beetle. through from 2007 to 16 anyway. Again, it's, you know, all over the West, where tamarisk is all over the place in the Western riparian areas. So our methods, you know, or cut stump method, you know, chainsaw, or it's very labor intensive, but it works. The beetle will not meet these objectives. If you got an area you want to do restoration on, the beetle isn't going to be your answer. It's just going to help you. You still have to go out and do selective treatments like this to actually control and meet your site objectives. So what you got to deal with is slash, that gets expensive. Chipping's more expensive. Here's the mastication that we're doing out with the BLM in the county on the Virgin River. It's really good on half beetle killed tamarisk, and they're mulching it up, and then we come in and use basal spray treatment and control it with the herbicides, because it all resprouts after fire or mechanical. It's called the low volume basal spray. This is us gridding out after the floods in 2005 on the Virgin River, and then 2009-10 floods wiped out massive old growth of tamarisk. And so we're coming in and selectively gridding and treating tamarisk so it doesn't establish and the natives can establish or reestablish, so the natives can. And we've had great success along with the beetle. The Virgin River has gone through massive changes in my career. Used to just be dominated by tamarisk, and now it's mostly dominated by native species. These are examples after wildfires. We use that because tamarisk, the biomass is very expensive to control. So if we get a wildfire, then we come in and use this selective treatment so it kills it. Let the fire, we do prescribed fire, and that costs money. And so if the wildfire occurs, we get funding for that, and then do the tamarisk control afterwards. And then you can help, it'll help allow native plants to come in. This is at Canyonlands National Park about 20 years ago, a big fire there on the Colorado River that we worked in. We had helicopter hauling in our stuff. Now, some Gold Butte stuff more specifically you're all familiar with. I think these are some of the springs throughout Gold Butte. Now, historically, our priority for tamarisk strategy was these springs and side drainages. Okay, so we know the Virgin River, Lake Mojave, the Overton Arm, Lake Mead, Colorado River system in general is loaded with tamarisk, right? We had that was low priority. We did not want to try and spend any money in most cases along these areas. But thankfully the biocontrol is there. The tamarisk beetle is helping reduce those areas where we wouldn't want to spend our efforts. But we have spent significant efforts over the last 30 years in the Gold Butte on remote springs. We've been to almost every spring and wash in the Gold Butte and have controlled tamarisk actively. And we're down to basically, if you find it, we want to treat it. So we've maintained a lot of these remote sites about every 3 to 4 years. Many of them took a decade to control them many of them. So here's some of the sites that we get funded with the Southern Nevada Public Land Management Act and the BLM agreement. This is called Bear Poppy Spring. It's in the Gold Butte. It is an area we recently conducted tamarisk control in for about 2 different years. And it's got a lot of water there, and there was a lot of tamarisk. And again, it was a remote, lots of hiking. Here's some example of some treatment polygons. There's several series of spring heads that come out of this escarpment here. And then this larger one we did control on the next year. These are treatment polygons, and that's untreated areas in the first year. We got legends down here that show what we did. Red Rock Spring is nearby. Gold and Bear Poppy, we're treating it tamarisk there more recently. Here's Skerpa Spring, which is up, I mentioned. Here's Rogers Spring right here off North Shore and Lake Mead. Here's some areas we did tamarisk control and palm tree control. Red Bluff Spring, this is an old one I worked on. That was a big priority. It's one of the larger springs in the Gold Butte. It's got lots of native vegetation, but they had a tremendous amount of tamarisk. We had to set up a remote base camp with a wall tent and work for weeks upon weeks with 8 to 12 person crews chainsawing this stuff out and then burning piles afterwards with the fire crews. And then we revegetated it with honey mesquite, catclaw, desert willow, screwbean as well. And then this red boundary is the park. So we went all the way down from BLM into the parklands. Here's another polygon. Cataract Wash, that's out in the Gold Butte, the middle of nowhere. We controlled all the tamarisks there. That was back 2005. Here's a Catclaw Wash polygon there. Aethel tamarisk, I'm going to be finishing up here. This is an evergreen tamarisk that was thought to be benign. It's used as an ornamental. It was spreading. We found in late 90s thousands and thousands of these trees growing along the shoreline of Lake Mead, and we've since controlled them, pretty much eradicated, probably in the 40 or 50,000 individual trees. These red polygons are the different germination events that occurred as the lake recedes. This is a germination line. This was the shoreline here. This was the shoreline at one time, and you have different age classes of Aethel tamarisk. It's evergreen, so it was actually produced from seed. So these are germinating from seed. Here's an example of a sapling or Aethel on Boulder Beach. So it's establishing in those places. This is on the Havasu Refuge. So much Aethel tamarisk, it caused a huge wildfire, and we've been doing lots of control down there afterwards. Tree tobacco is another woody perennial, less widespread. Russian olive, I'll speed through that quite a bit. That's a morely Colorado plateau species, Utah, certain parts of Nevada, Arizona, and Colorado. It's a big problem. Wyoming, Idaho, big problem in Idaho. We developed effective methods for control of that. We do that on our partners in those other states. Paranagate valleys where the most Russian olive is that I'm aware of in the state of Nevada, and there's a CWMA there, Cooperative Weed Management Area, and we've worked with them and done lots of Russian olive control in the Paranagate Valley. And just in closing, I want to acknowledge all the invasive plant management team members over the last 25 years, all of our partners that I mentioned earlier, some of these citations as well, and then our data managers over the years that help provide these maps and polygons and our data work. Megan Stevenson helped with some of the slides here, and then again, any of our crew members. I think Riley Gronemeyer and Josh Vogel I saw, maybe some others have joined, but couldn't. All this is thanks to them. They're the ones doing the work out in the field, doing all the hard work. And thank you. There's my contact information, and if any of you are still on or interested, I'd be glad to entertain any questions or address any.
There are some questions in the chat, and I'm happy to read them if you'd like.
Okay, great. Let's see. Can I? Oh, well, maybe I'll stay on in case I need to go back to anything. But sure, go ahead.
Okay. Do you use satellite photos to identify areas that require remediation? And how do you identify and prioritize what to remediate?
We don't use satellite photos probably as much as we could or should on. We use aerial imagery as a backdrop for our data collection. And so that comes into, those are basically a lot of those can help on landscape scale. Some of the satellite imagery hasn't really been developed for certain species. We can't detect at that scale what species is with what, and so, yeah, we have no problem finding areas to remediate just by using our 2 feet or vehicles. So that's kind of how a lot of that's been done in the past, or continues to be done. We don't have any trouble finding places to treat, let's put it that way. But I'd love to be able to use that technology on a more large scale. It's developing. It's certainly in developing. I think it's underutilized. I'd like to use drones more for surveying, particularly like Joshua Tree, or helicopters to survey some of those remote areas at Joshua Tree.
This question's from Jim Boone. When we post observations of these weeds to iNaturalist, do you use that data?
Good point. Thanks, Jim. Yes, I would say it's very, very important. I encourage you all to use iNaturalist to photo these. And then also there's another one, an app called EdMaps. That's a really good one. And it's for more invasive species, plant species, but it actually includes all taxa now. But what those systems do is they get notifications, and then there's verification process, and then it can end up being used for control or going out in the field to verify. The state of Nevada Department of Ag is actually really working on an early detection program in each region, and we are using EdMaps as our main app, but iNaturalist data can feed into the EdMaps program as well. But yeah, I think any of the information, if any of you are out in remote areas, Gold Butte areas, and you see tamarisk, there's tamarisk out at Gold Butte, as you all know, but we have pretty much a zero tolerance for it above the Lake Mead shoreline anyway. So if you find anything, take a point. You can always send me an email, but yeah, or the BLM counterparts.
Okay. Another one, to piggyback off of Jim's question, how are non-native plant populations monitored?
Well, that can vary. Usually our treatment areas, we monitor from year to year. We'll go back to some of the same areas we have treated in the past, and you can determine effectiveness, or our partners will do follow-up monitoring. That's usually up to the partners, and the intensity level can vary. Just observationally to some plot work, that kind of thing. But most of it's surveyed either by vehicles or on the ground.
This one is, will continued grazing at Gold Butte make it more difficult to control red brome and cheatgrass?
Actually, grazing can play an effective role if it's timing, actually, to reduce red brome and cheatgrass, because it is palatable at during green stages. So it can reduce the fuel loading eventually. But of course, I don't think there's any authorized grazing in Gold Butte in general on the landscape out there. I think some of the biggest problems with some of the cattle use out there are some of the riparian areas and trampling and excessive vet eating in the restoration sites and all the sites out there as far as restoration goes in the wetlands and spring fed areas. Yeah, I don't know. Did I answer that one well enough? Or? I don't think, let's see. Yeah, it's the seed banks out there in general. So grazers can be used to reduce annual fuel loads. Let's put it that way.
This question, if palm trees are invasive, why do we allow them to be planted here in Southern Nevada? And also, how do these herbicides affect the native vegetation? Thank you for the informative talk.
Oh, great. Thank you for the comment. Let's see. Palm trees are they're ornamentals and aesthetics, and people like them, and development likes them. They are not state noxious. They're not on the state noxious weed list, so it isn't illegal to plant them. So it's just some areas we don't want to accept them as they expand beyond the urban areas or landscaped areas. And so we're doing active control in those areas to maintain the natural community. As far as the herbicides go, I think I referenced several times in my presentation, herbicides have different characteristics and qualities, and if used appropriately, they can be a restoration tool. And if applied, it depends on how they're applied as well. So each herbicide has a different active ingredient and compounds in it that can give benefits and could also be detrimental if not applied correctly. You got to apply them according to label. But I think, and what's mostly what I reference and how our methods are is how you apply them. So almost all of our applications have a person attached with eyes and hand, and they selectively apply it to the target weeds. And so we can avoid the impacts to the desirable species nearby.
This one's more of a comment than a question. It says, saw several tamarisk in Cottonwood Canyon southeast of Gold Butte in April this year, and saw 2 live T. aphylla in Echo Wash at Lake Mead recently.
Oh, okay. All right. So Cottonwood Wash. Some was that Aethel at Cottonwood Wash?
Echo Wash.
Well,
So,
yeah, Echo Wash. Okay.
and then the tamarisk were in Cottonwood Canyon.
Cottonwood Canyon. Okay. Not exactly familiar with that exact location there. Yeah, Echo Wash is another long-term. We did control from Bitter Springs all the way down to Lake Mead itself. 20 some years ago, we did massive amounts of tamarisk control there. I have never seen Aethel tamarisk there. That's a good report. So we're actually planning to do retreatment in those areas with the SNPLMA funding, and we'll treat Park Service and BLM, and we'll be on the lookout for those Aethel then. That's important.
And
Thank you for the report.
Is there an opportunity to help your team through volunteers? We have many hikers in the Mesquite area that could help your team with things like carrying water in or physical removal.
Yeah, there could be some scenarios that we could maybe use that on, but it's pretty hard. Planning with volunteer efforts takes a tremendous amount of work ahead of time, and so we'd have to figure out that all in advance, and that can be difficult.
There's one that came in on my email. This is from a lady that couldn't for some reason log on to this presentation, and she said she wanted to ask a question about how to remove sacred datura from a community garden she volunteers at.
Oh, okay. I would probably just hula hoe that or hoe it out. Hand pull with gloves. I think some of the plant itself, well, it has lots of fine hairs on the stems, so that's very irritating to the skin. And I believe there's obviously some toxicity in the plant too, because the seeds are toxic. So, so I would make sure to wear gloves. You can hand pull it. I don't think it's all that hard. Just of note, it is a native species. It's not a target weed by any of our work that we do.
Okay, that's all the questions that I see in the chat so far. Oh, here's one more. She's typing. But if anyone has anything that they would like to ask verbally, you can unmute yourself to do so, but I'll take the chat questions. Let's see. Okay, here we go. I would love to hear about any other efforts to monitor treatment results. I really enjoyed hearing that there is a group at Arizona taking advantage of some of these treatments in research. Are there any other groups doing any treatment monitoring or using your work to further understand native plant effects, or excuse me, to further understand invasive plant effects on native plants?
Okay. Let me just realized. See if that's any better. I've been talking in the dark here. Okay, so yeah, the monitoring, that really varies. We do some intensive plot monitoring in areas. It's opportunistically, like some of our areas where we use prescribed fire, we have fire effects plots in that are kind of precise. And then there's some inventory and monitoring programs that may opportunistically monitor our treatment areas. But yeah, let's see, what else was the aspect of that question?
Any other groups doing any treatment monitoring or using your work to further understand invasive plant effects on native plants?
Well, what we do is, yeah, we record all of our, geospatially record all of our treatment areas and survey. So we can at least go back, or it can be a data set that could be used by others to do more intensive monitoring. Most areas with our partners, they're pretty committed. Their areas are prioritized. So they get treated or monitored year in and year out to see if it's, to see, what the response of the weeds are from year to year. Most of it's observational monitoring.
Kevin says a lot of previously treated athel resprouting on the east side of the Muddy River.
East side of the Muddy River, athel. Okay. Yeah. I'm not aware of athel being up there, but that's, we had a lot of tamarisk control work in there, but is there a particular spot of athel? Is it like down in the town of Logandale area or Overton, or is it up in the Warm Springs?
Maybe he'll type something else. But while waiting for him, this is another question. Are there aquatic plants that invade riparian areas that you control?
No, we don't. We have not worked with like submerged aquatic plants. We have worked with emergent, like cattail. We do quite a bit of cattail control and Phragmites in the wetlands park or on Lake Mojave, where they're rearing native fish, like native fish habitat. We've done some there so they can get access to nets, but we haven't done any true aquatic vegetation.
Okay.
Or,
Renee says, thanks for that, Curt. Sounds like there's a lot of opportunity out there. And I don't see anything more from Kevin regarding the athel resprouting. Oh, yes. Near Overton, south of the end of the Muddy River access road on Bureau of Reclamation property.
Okay. All right. We'll keep an eye out. We have some agreements with the Bureau of Reclamation. Keep an eye on that. I think I know some large ones that were planted kind of along the road there, but
any more questions, anyone? Any verbal questions? Hearing none. I would like to thank you for presenting tonight, Curt. I really appreciated it. We've waited a long time to hear from you. And thanks so much. It was very informative. And okay, wait, here we go. Yeah, thanks for sharing your info. Weeds are a big problem, so it's good to hear about how your team is working to control them and educate people. That's Jim Boone. Thank you, Jim, for being here too.
Yeah, thank you.
If anyone else has anything they'd like to say or any questions, we got a minute more. I don't see anything. Well, Curt, thank you so much. I appreciate it, and I know everyone that was here tonight does, and anybody watching on Facebook or that will watch the recordings.